Assalamu alaikum everyone. Today we will discuss alkanes in O levels chemistry. Alkanes is the first component of organic chemistry. So the code for O levels chemistry is 5070 and the chapter is organic chemistry and alkane is its first component. So let's get started. Firstly, you should remember that how to identify alkanes. Alkanes always end with ane, alkane. The journal formula for alkane is CnH2n plus 2. Now, let me tell you a few more things about alkanes. Alkanes are saturated hydrocarbons. What does what it is meant by saturated hydrocarbon? Saturated hydrocarbon means no more addition is possible. It means that alkanes only have carbon single bond like this. So carbon belongs to group 4 and it makes 4 bonds. Alkanes are saturated hydrocarbons and they have carbon single bond. The smallest alkane is methane, which is CH4. The CH4 is molecular formula. However, this CH here one hydrogen, second, third, and this fourth hydrogen. So this is a displayed formula for methane. Okay. To make organic chemistry easy, you have to memorize few prefixes from 1 to 10. So let's write them. The prefix, you have to memorize them. They aren't given in the exam. First one is meth. This meth means 1. Second is eth, which means 2. Third is prop, which means 3. Fourth is but, which means 4. The fifth prefix is pent, which means 5. Sixth prefix is hex, which means 6. Seventh prefix is hapt, which means 7. Eighth prefix is oct, which means 8. Ninth prefix is non, which means 9. And the 10th prefix is dec, which means 10. You have to memorize these prefixes from 1 to 10 to write the formula or the molecular formula of organic chemistry. Now let's move further towards branched and unbranched structures. Let me tell you what are branch structures. So branch structures are those structures that have two paths of carbons. Two paths of carbon. Let me give you an example so you can have a clear idea of branch structures. For example, this is first carbon, second, third, fourth. So we have 4 carbon here. It means that it is butane. And let's add a branch here and we have branch on the second carbon. So when we have a branch on the second carbon, so you can see that carbon have 2 paths. Firstly, it can go straight here 4 carbons. Secondly, it can go like this and here are 3 carbons. Thirdly, it can also go like this and in this way it will have 4 carbons. So this is the branch structure, and the branch is on the second carbon. So here I'm telling you a trick to identify the unbranched structure. To identify the unbranched structure, you have to just see that if the branch is on last or first carbon, so they aren't branch structures because the branch is on last or first carbon and the carbon do not have any other path. It only have a single root due to which it isn't a branch structure. Let me give you an example. For example, this is a three carbon alkane, which is propane, and the branch is on the last structure. So this last one is known as this last end of the branch of the carbon is known as terminal. When the branch is on the terminal, so it is the structure isn't called branch structure, it is called unbranched structure. This is unbranched, and because of terminal. I hope you understood the difference between branch and unbranched structure. What is terminal? Is the terminal is the end carbon. I hope you understood it. Now let's move towards the rules to identify or to name the alkane. The rule for naming are, firstly, you have to identify the longest chain of the carbon atoms. When you have identified the longest chain, you have to identify the branch and the position of the branch. When you're done with the first step, you have to do second, and when you're done with the second step, you have to do the third step, which is number the chain from where the carbon connected to the branch get the smallest number. When you have done the third step, you can easily name the structure. So let me give you an example here. 1, 2, 3, 4. This is 4 carbon, which means it would be butane. Now, while looking at the carbon, you have identified that which alkane is it. Then I'm making branches here. I have made branch on the second carbon. And this is a methyl branch because here is one carbon only. So let me write all the hydrogens. It is necessary to write all the hydrogens, but because if you miss to or if you forget to write these hydrogens, your formula or your displayed formula would be incorrect. So you have to name this structure that I have drawn right now. It contains 4 carbons. These are the 4 carbons. It means it is butane, and it have a branch on its second carbon. Now you have to number the branch from where it gets the smallest. Let's number it 1, 2. Here the branch gets the smallest number, which is 2, then 3, then 4. It's going straight, so let's name it. It would be 2 methyl butane. It is methyl because it have 3 hydrogens. And this is the position of the branch. This is that it have either methyl or ethyl, whatever. And this is the number of total carbons in the structure present. Let's have a look at one more example. So in this, the structure is drawn, and you have to tell that what is it. Here is the hydrogen. Here is the hydrogen. You can see that there are in total 1, 2, 3, 4, 5, 6, 7, 8 carbons. Let's see the longest chain. So the longest chain is starting from here and going here and here. This would be 1, 2, 3, 4, 5, 6 carbons. So the longest chain is of 6 carbons. What if we started the chain from here? 1, 2, 3, from here. 1, it would be like this. 1, 2, 3, 4, 5. It is having 5 carbons. So the 5 carbon 6 chain is longer or 6 carbon? Obviously the 6 carbon chain is longer. So we will start the chain from here that I've told you first. Let's label it. So it's 1, 2, 3, 4, 5, and 6. Okay, now let's name it. So we have two methyl, one on the second carbon and one on the fourth carbon. So 2 and 4 methyl, and we have 6 carbon, it would be hexane. So the full name is of this structure, it is 2-methyl hexane. I hope you understood it. Now let's move towards the next example. This time I would be drawing the structure and you have to look at it. Mhm, 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 mhm. So the branch is on the second carbon. If we start counting from left or right, the branch will remain on the second carbon. So let's start from left, 1, 2, 3. And the branch is on second carbon. So we will like 2-methyl propane. It is propane as it contains 3 carbon. If we see like this, so here are also 3 carbon, and if we see like this, so here are also 3 carbon. Now let's move towards isomer isomerism. What is this? Isomers. I hope you have heard the term isomers, and this is the thing I'm going to tell you is isomerism. In organic compounds having same molecular formula but different structure formula are known as isomers. They have same molecular formula but different structure formula. Same molecular formula, different structure formula. Now, by seeing just two few examples, you can easily identify the isomers. And the question comes in exams like that, like what are the possible isomers of structure C6, C4H10? This is one of the common question that comes in exam. and it is most frequently repeated, and it always, or you can say that mostly it comes of C6H10. C4H10. So this is an alkane. Its general formula is CnH2n plus 2. C4 carbon are 4, and 4 twos are 8 plus 2 hydrogen are 10. So let's draw the possible isomers of C4H10. So the first isomer is C. What does C4 mean? C4 means 4 carbon, which is butane. So the first isomer is very easy. You can simply draw butane. Don't forget to put the hydrogen. So this is butane. Let's draw the second possible isomer for C4H10, and I'm drawing it with red. It would be like this. So you can see that here the molecular formula is same, but the structural formula is different. There are 4 carbons. The molecular formula is same, but the structure is different. And it is methyl propane. It isn't necessary that you in when you are labeling the when you are naming the alkenes, the carbon starting the chain starting with the 4 carbons, you have to label the number of, or the position of the branch. While if the chain is starting from 3 carbon, so it isn't necessary to label or to write the position of branch. So you can simply write it like it is methyl propane. The name is different, but the molecular formula is same. However, the structural formula is different. Okay, let's draw another structure of C4H10. Many students would be drawing it like this: 1, 2, 3 carbon, and there is 1 carbon at the end. So what do you think? Is this structure correct? Let me tell you that this structure, which I'm drawing right now, saying that it is third possible isomer of C4H10, this is totally incorrect. How? Because the it is incorrect because the branch is on the terminal, and I told you that if the branch is on terminal, so it isn't count as a branch structure. So this is only propane, and its formula is C3H8. It isn't butane. Its formula isn't C4H10. Its actual formula is C3H8, so it is incorrect. Let me tell you one thing, that C4H10 only have 2 possible isomers. As the C4H10 is mentioned in the syllabus of Cambridge, you can check it out. So you should know that it only have 2 possible isomers. And if this question comes in exam, so you have to draw 2 possible isomers, because in the question it is written that you have to draw the all the possible isomers. All the possible isomers. It isn't mentioned that it is 1, it is 2, or it is 3, or it is 4. So you have to remember this, that C4H10 only have 2 possible isomers. I hope you understood this. Thank you.